Okay, this is our second video on circles. I'm going to do an example here using number 54. And so what we're going to see here in some of the exercises that you'll have to do is you'll have to graph some circles that aren't in standard form. So recall here, standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. So notice number 54 doesn't look anything like that. So what the directions tell you to do is to complete the square so you can get these quantities squared, and then that's what makes it go to standard form. And of course, the radius squared, you'll have to sort of throw it on the other side. So what I'm going to do here first, this is the 16. It's just the constant. So what I'm going to do is just throw it to the other side. Now, I'm going to rewrite it so that my x terms, my x squared and my x terms go together, and my y squared and my y term there goes together. And the 16 we'll just throw on the other side. So we'll get x squared plus 8x plus y squared plus 4y equals negative 16 there. Okay, so now, move this down a little bit. We're going to complete the square so we can get this quantity squared idea. So recall here, and the thing is, we're going to complete the square twice, once for the x and once for the y. So we'll go x squared plus 8x plus, and then we'll complete the square here in just a second, and then now plus y squared plus 4y plus, there again, something to complete the square, equals negative 16. And whatever I add on the left side there to complete the square, I'll also have to add on the right side. Okay, so let's recall how to complete the square. We're going to take the linear terms, and we half and square. So half of 8 is 4, and 4 squared would give me 16. All right, so I'll complete the square again for the y term. Half of 4 is 2, and 2 squared would be 4. So now I've added a 16 and a 4 on the left side. Now I'm going to add a 16 and a 4 on the right side. Okay, now what's going to happen is now that we completed the squares, these are going to be perfect square trinomials there. So recall that a factor of perfect square trinomials, we're going to take the square root of the first and last terms and use the first sign. So that would give me x plus 4 quantity squared. And now for my y part here, the square root of y squared would be y. The square root of that 4 would be 2. And again, I'm going to use the first sign. Okay, now on the right side, let's combine all those terms. Negative 16 and 16 would just be 0, and so that would just leave me with 4. Okay, so that's how we get it to standard form. Now the rest of it is something that we've already done, and let's just graph the circle. So to graph the circle, we need to identify the center, which would be negative 4, negative 2. And then my radius, now recall, this is not the radius. 4 is not my radius, but that's my radius squared. So my radius here would really just be 2. So on my graph here, I'm going to graph the center of my circle first at negative 4, negative 2. And then the radius is 2, so I'll go 2 up, 2 to the right, 2 down, and 2 to the left to get my circle here. Okay, let's take a look at another example of this one, of putting it into standard form here. Now notice on this one, we have a y term to go with my y squared, but I don't have an x term to go with my x squared. Well, that's actually kind of good news. So what that's going to mean here is I'm not going to have to complete the square for the x's. So the only time I really have to complete the square is when I have a linear term in there stuck with it. Okay, so I have to complete the square with the y's, but not with the x. And now 7 here, we're just going to throw him to the other side. So let's copy this down again here. We got x squared plus y squared minus 6y. Now, I'm going to complete the square, so I'm going to say plus blank. We'll throw 7 on the other side and say plus blank there. Okay, so now all we have to do is complete the square for the y only. So let's think about there. Half of 6 would be, I don't know, I'm writing that down. I just write right here. Half of 6 would be 3, and then 3 squared would be 9. So if I add 9 on the left side, I'm going to have to add 9 on the right side also. So we'll get now x squared plus, now let's complete the square here. The square root and the square root there would be y and 3. And I'm going to use, remember that first sign there, so it's going to be y minus 3, quantity squared. And then 7 and 9 would give me 16. So I didn't have to complete the square with the x term because I didn't have sort of a linear term to go with that one. So that means the center is going to be 0, 3. And now my radius is not going to be 16. 16 is the radius squared, so the radius would be 4. So now I'll go 0, 3 for my center. And now I'm going to go 4 units in all 4 directions from the center. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Kind of messed that one up a little bit there. All right, not a very good circle. Okay, now something else that we're going to need in this lesson to review here is the distance in the midpoint formula. So let's start off here. Let's find the distance between these 2 points. First, let me remind you of the distance formula here. So we have, it's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now there are a lot of things in this formula here that you can get backwards. If I get these 2 things backwards, it's not going to matter. The only thing that would change is it would be a negative number instead of maybe a positive number, but if you're squaring right there, it doesn't matter. So this formula is, it's not really hard to mess up here. So let's look at the x's first. And there again, it doesn't really matter what I call x2 and x1. Okay, so x2, I'm just going to call it negative 4. So we'll get negative 4 minus 2 quantity squared. Okay, now let's plug in our y's here. So our y's, we have negative 1 and negative 3. So they'll give me negative 1. Now, minus negative 3 would really make that say plus 3 quantity squared. Okay, now, before we square here, we're going to do what's inside the parentheses first. So now, if we square, or if we subtract first here, negative 4 minus 2 would be negative 6. And then negative 6 squared would be 36. So no matter what happens there, because I'm squaring, these numbers always come out positive like a distance should be. Negative 1 plus 3 would be 2. And then 2 squared would be 4. And so now the square root of 36 plus 4 here. Notice, because of this addition, I can't take the square root of this number and take the square root of this number. I have to add first. It's sort of like that they're grouped right there. So this would just give me the square root of 40, which we can simplify. We can say 4 times 10. So this would be 2 square roots of 10 there. And let's kind of go back on this. The directions didn't say simplify. It actually said round to 2 decimal places. So it didn't really actually cause for me to simplify. So all you have to do now is just throw that in the calculator. So the square root of 40, I can't find my calculator. All right, 6.32 is there, what it really is there. Okay. All right, now, so we're going to see an application here. We're going to use this in helping us write the equation of a circle later. Now, let's look at number 22. Now, this one asks to find the midpoint between these 2 points. So let's go over our midpoint formula here. Is x1 plus x2 over 2. That gives me the x-coordinate. And then y1 plus y2 over 2 gives me the y-coordinate. So now let's plug these in. So my x-coordinates, we're to say negative 4 plus a negative 1, which would really just be minus 1 over 2. And then for my y coordinate here, negative 7 plus a negative 3, which again would just be really minus 3 over 2. Now let's simplify these. Negative 4 and negative 1 would give me negative 5. So that'll just be negative 5 halves. And then negative 7 and negative 3 would be negative 10. But negative 10 over 2 would be negative 5. So again, this would be the point that would represent halfway in between those 2 points here and here. Okay, let's look at another example, this time one with maybe some fractions in it here. So here we again, the x-coordinate is x1 plus x2 over 2. Y-coordinate is y1 plus y2 over 2. Of course, we put it in parentheses here because it's an ordered pair. So x1 plus x2, so that's going to give me negative 2/5. And then plus a negative 2/5, which would be just minus 2/5, all over 2. And then y1 plus y2, so I'm going to say 7/15 plus a negative 4/15, which would really just mean minus. Okay, all this over 2. Okay, so let's calculate here. Negative 2/5 minus 2/5. Notice I'm subtracting, so the denominators are nice and common there. I'm just going to do the numerators. So that's going to give me negative 4/5 over 2. And then 7/15 minus 4/15 would be 3/15, which I could just reduce to 1/5 there, over 2. Now that looks pretty complicated, so what we're going to do here, instead of thinking of it as negative 4/5 over 2, this would just be negative 4/5, and think of dividing by 2 would just be to multiply by the reciprocal. The reciprocal of 2 would be 1/2. Okay, now I could cancel here. 2 would go into 4 2 times, so that's going to leave me with negative 2/5 for my x-coordinate. Now for my y-coordinate, the same thing. 1/5 divided by 2 really means to multiply by the reciprocal, which would be 1/2. And so that gives me 1/10. Okay, so there again, that represents the point that's halfway in between these 2 points. Now let's look at the application where we're going to use our distance and midpoint formula. And I'm actually not going to work these 2 problems out. You are. I'm just going to kind of help you figure out what you need to do. So it says that the line segment through the center of each circle intersects the circle at the point shown. Okay, so let's just kind of look at 65 here. So we've got 2 points. All right. And then here's our other point. Okay, so it says find the coordinates of the circle's center. So the center, of course, is halfway in between. So what you're going to have to do first on part A, the point that's halfway in between here would be the midpoint. Okay, and so that's going to obtain the center of your circle. Now, for part B, it says find the radius of the circle. So I'm not sure what that midpoint is. I'm going to label it x comma y. And so to find the radius of the circle, the radius would be the distance from the center to a point on the circle. So I'm going to use the distance, a distance formula, to get from the center to a point on the circle. And that's going to tell me what my radius is. And now once I have the center and the radius, then I can do what it says in part C, is write the standard form of the circle's equation. We'll leave those 65 and 66 for you to kind of figure out there.